just to go over your quiz, if you're going to retake, you need to do this. Um, System of equations is kind of like the quiz you took, only now you get the chance to look at it again. So the first thing you do here is, the question is with this picture is, what's the system? So I'm going to look at this line first, and I'm going to write the equation for that one. This one has a y-intercept of -1, and it has a slope of rise 1, run 2. So its slope, rise 1, run 2. Giving you the equation y equals 1/2 x minus 1. This equation, this line here, has a y-intercept of 1 and a slope of, that's what's a little bit more difficult to see. Let's see, down 3 over 1. Down 3 over 1. So its equation is y equals -3x plus 1. Now, you have the system. The only thing different now is we got to look at the shadings. So looking at the red shading, the red line, first of all, it's dotted, so it can't be equal. And it's shaded below. If you take the line and you go down, it's shaded below it. That means this is less than. For the green one, this one's solid line, and it's shaded above. So therefore, it's greater than or equal to. So there is your system that we would be looking for. Now, as far as are they solutions given points, what you're looking for is the actual points and see if they fall in the shaded region. If it's on the dotted, it's not included. If it's on the solid, it is. So -2 zeros here, that is a solution, yes. -4, 4 is located here. Yes. 4, -4 is down here. No, not in shaded region. -2, -2. Oh, that one's got to be careful. Now that one is on the solid line. That is equal to. So you do include that one. If it was dotted, I would not. 0, 1. There you go. There's a dashed line. That's on the dash. That does not include it. So no. 0, 0, -2. Located here, not in the shade region. No. Okay, that's how you do inequality systems. Now here's your favorite thing, word problems. First statement says he's selling 2 sets of types of fruit. You got, or she is, you have 4 apples and 9 bananas for $43. So that must mean 4 per apple bundle plus 9 per banana bundle is 43. That's one equation. The next statement says she sells 27 apples and 1 banana bundle for 111. So that's 27 per apple plus 1 per banana equals 111. Now you have the system, that's good. Now we need to solve it. Now we got our choices of way of solving it. We can solve it by graphing, which means I'd have to solve both of these for y. I really don't want to solve that top one for y. The bottom one, it would be no problem. Or I can use elimination, which means I need to solve one of these for one of the 2 letters and plug it into the other equation. And the last one is elimination. I could use elimination here, but I'll get to show you elimination on the next example. Right there, I would probably multiply this bottom row by -9 if I was going to do elimination here. That would allow this to be 0. But since I've chosen not to do that, I'll show you using substitution on this one. So to substitute, I'm going to take this equation here looks the easiest to solve because I can solve this y and get it by itself real easy by subtracting 27x from both sides. That would give me y equals 111 minus 27x. Once you have this, I'm going to box it, and I'm going to bring it up here and plug it into this function. So 4x plus 9 times y, which is 111 minus 27x, equals 43. Distribute 4x plus 999 minus 9 times 27. Now you can do that in your calculator. I'm going to do it in my head. It's 81x equals 43. Add your like terms. Negative 70, 78, nope. 77x plus 999 equals 43. Subtract 999 from both sides. And then negative 76 equals negative, I know, beautiful question, 956. And now divide by negative 77. Don't panic. I'm doing some of that in my head. So x equals, not a good question because I don't know. Let me cheat real quick. Let me put that in my calculator. Give me a second. Here we go. In my calculator. 956 divided by 77 equals. Uh-oh. I have a mistake somewhere. I got 12.4 something. Not a big deal. Mistakes are meant to be made. I see my mistake already. I did 27 times 9 in my head, and I got 81. That was supposed to be 243, you ding dong. So that should be 243, which changes this guy, which changes this guy, which basically changes all this work right here. So let's do that real quick. So I've got 243 was supposed to be here. I was supposed to add like terms, which should give me, hopefully I can do this one right in my head. Add your two like terms gives you negative 239. So I got negative 239 down here. Now I'm going to divide by 239. So 956 divided by 239 equals 4. So divide by negative 239, divide by negative 239, x is 4. Now, I boxed it for a reason. Come back over here, plug in your 4, and you get hopefully a nice pretty answer. 111 subtract 27 times 4 is 3, which tells me x is 4, which was my apples, so they sold for $4 is how much you sold the apples one for, and your bananas you sold for $3. Okay, next question. This one's by elimination. Now, elimination, your first steps, I can ask you, what's your process here? Now, there's actually two steps that could work here. If I look at the x's, if that's 3, I want this to be negative 3. So I'll multiply that by negative 3. That gives me negative 3x plus negative 15y equals negative 39. Bottom, I get 3x minus y equals 9. Now, if I did this right, something should eliminate, which, see how it come down here and this becomes a big fat 0? Now I can just add down, which gives me this. And I can continue on, find y, and then go back and find the x value once I'm done. Now I could also, another choice is I could have not looked at the x's, I could have looked at the y's. So another reasonable approach would be to look at the y's. This is 5, so I want that to be negative, the bottom to be negative 5. So what I'm going to do is multiply this by 5. Keep the top the same. Multiply everything at the bottom by 5, which gives you 15x minus 5y equals 45. Now when you add down, the y's eliminate, giving you 16x equals 58, and then you would solve for x. That's just the first few steps there. But it's once you get the one x, you get x or y, you can find the other variable. All right. This was not meant to be a very difficult question, but the problem is a lot of people aren't reading the words. So I could have asked for x or the y value or just the solution. The solution is where the two lines meet. That point is -2, 2. That's my solution, -2, 2. But the words could have said find the x value of the solution. Well, that's just -2. And that would mean you completely didn't understand it if you wrote the actual solution -2, 2. I could have asked for the y value of the solution. Well, that's just the answer of 2. Back to another word problem. In this particular case, I've got this person sells spotted donkeys for this much per. That's another per. And then we've got purple donkeys. Don't ask me what that is. For $542. Now here they're indicating two different totals. The total number of, well, I don't know how many spotteds, so X. I don't know how many purples, so Y equals 45. The other total gives me the equation. Well, now that's talking about dollars. In terms of dollars, I have 134 per donkey spotted plus 542Y. So that's because that's purple, 542 per purple equals a total of 9294. Once again, this system you can solve either by elimination or substitution or by graphing. I really like this equation. It seems so much easier, and I could do this by substitution, I think. It doesn't matter. I'm going to choose substitution because that is my y, and I can bring that and put that right into the other equation for y. So I can bring this, put it right in there for y, and then solve like we did previously. Now you want to finish that up before you turn it in when you're reviewing. You should get two very pretty answers for your spotted and purple donkeys. And don't ask me what those are again. Okay. Yeah, I know sometimes you have to actually study in math. Here, if you have parallel lines, one thing you'll notice is they'll look something like y equals 3x, y equals 3x plus 7. The key tip here is that the slopes are the same. If the slopes are the same, they're parallel lines. If they're parallel lines like that, there's no intersection, so there should be no solutions or none. If they're exactly the same line, it's kind of sometimes hard to see, but what's happening is they basically, if you graph them, like here's an example. Y equals 3x plus or minus 2. That could also be written as -3x plus y equals -2. Both of these two things are exactly the same equation. Well, how would you know that? Go ahead and solve those both for y. Put them in your graphing calculator, and you'll see you get one line, then a second line falls right over top of the other one. That's overlapping, or the same line. That gives you every single point as a solution. So there's an infinite number of solutions. Well, intersecting, those are equations of any line, any two lines. Actually, any two curves, it doesn't really matter. But if they're two lines, they're going to intersect, and there's clearly just one solution. So those are three terms you really kind of need to understand. Okay, next question. Now it specifically tells me I have to solve this by graphing, which means I need my calculator, which means I'm going to use the y equals button. This one's already solved. I don't have to do anything. That one's ready to go. But this second equation doesn't say y equals. So what I'm going to do is I'm going to solve that one for y by subtracting 3x subtract 3x, I now have the equation y equals 13 minus 3x. If you put those two things in your calculator, you should see a screen that looks like this. One goes like this, one goes like this. You remember, to find the solution, hit second calc, number 5, which is intersection, and then enter, 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 and that's going to give you your solution. Again, that should come out pretty, so finish that up when you're doing the assignment. This last one, question's asking you, are there solutions? Is this point a solution for either one of these? Well, if it's a solution, then it must make the statements true. So I'm going to use the point x is -1, y is 3, and we'll check it in here. So take out the y, and in its place put 3 equals 9 times -1 plus 12. Well, if I do that, that's -9 plus 12, which is 3. So that statement is true, but it also must be true at the bottom. So I take the second equation, plug in my y, plug in my x, and I get 3 equals -5, subtract 6, 3 equals -11. What? Not true. So this is not a solution to this function. So that function doesn't work. Now we try this one. Again, I'm going to take these 2 points, this x and y, and plug it in here. So 3 greater than 3 times -1 minus 2. 3, is that bigger than -5? Well, yeah, that's a true statement. Now I'm going to take the other equation, this one, and I'm going to take the two numbers and plug them in. -2 subtract 3, is that less than 1? -5, is that less than 1? Heck yes. So -1, 3 is a solution to this one, so yes. Okay, make sure you go through it, go through your quiz you took, and then you may come in and ask any questions, and you can reassess.